Next, we'll look at another piece of functionality that is exclusive to TypeScript. It doesn't exist in JavaScript, and that is abstract classes. So here's a super short version. We can have some class, like cat. And if I put the abstract keyword or modifier in front of that in TypeScript, that means something. We'll get to what that means. But the first thing it means is that I can no longer create a new class on its own. Or a new instance of cat, I mean. If I try and instantiate a cat, cannot create an instance of an abstract class. So then what is the point of having a class that you can't create instances from? Well, what we do with an abstract class is we define a pattern, we define methods that must be implemented by a child class. So instead of cat, my example that I'm going to do is an employee abstract class. So we'll have employee, and then we'll have at least two subclasses that inherit from employee: full-time employee and part-time. So what we're going to do here is specify in the employee abstract class, first of all, just some regular functionality. We'll have a constructor that says you got to have a public first name that's a string, public last that's a string. Okay. And I need my curly braces. This is nothing new. This is just a constructor with a little shortcut to make those properties for us. And then this is not JavaScript or TypeScript. But now what I can do in here is define methods that must exist in subclasses. So I can say, using the abstract keyword, that every instance of an employee subclass, so full-time employee, part-time employee, anything that implements this, must have a method called, how about getPay, which returns a number. So this method doesn't exist here. This is simply saying that it needs to exist in any class that extends employee. So you might be thinking it's kind of like an interface in the sense that we're saying, in order to be an employee or to implement this class or extend this class, you must have this method. But there's a key difference, which is this is an actual class with functionality. I can have a method in here like greet, right? And in here it can console.log, hello, just keep it simple. An interface can't do anything like that, right? An interface is solely describing the shape of an object, but this is kind of a hybrid. This abstract class has functionality, it has data, but it also says, by the way, you must implement a getPay method to extend this class. So it's enforcing some type stuff, and it's also adding functionality in. So it's a little bit of a hybrid. So now if I want to extend employee, like if I want to make my full-time employee extends employee, I immediately get an error saying you're missing your getPay method. So I could start with a real simple version. GetPay simply returns some random number, 13. It's not random, but it returns 13. And now we've satisfied that requirement. Let's do it again. Class part-time employee extends employee. I can have whatever I want in here. Whoops, extends employee. But I must have a method called getPay. So getPay, and that's going to return some number. And sure, I can annotate it if I want. It's kind of obvious. I'm just returning 13. It's going to be a number, but I'll put that return type annotation. So again, this is a rule that we set up in our abstract class. We use the abstract keyword first to mark it as an abstract class. I no longer can instantiate any instance of employee itself, but I can mark methods as abstract, and I can have as many as I want. And that means in the subclasses, full-time employee, part-time employee, whatever else we have, international employee, visa employee, executive level employee, they all must implement a method called getPay that returns a number. And additionally, they'll have a first name and last name. They'll have a greet method and whatever else they want. So they're still inheriting functionality. They're also inheriting a constraint or a rule that they must follow. Okay, and then the last thing I'll do in this video is actually implement these a bit better. So full-time employee will just have a salary. So let's add a constructor here. And that will accept a first name that's a string, and we'll pass it on up to the parent class. Last name is a string, and then salary is a number, just like that. And then in the constructor here, I'm going to, and I'll make that a public property or maybe private, just like that. And then I'm going to call super with first and last, because that's what employee is expecting, first and then last. And then this shortcut, this syntax, is what actually makes those properties, right? It's doing the this dot X, this dot first, this dot last. I'm just passing them on up the chain here. And then we're setting salary using that shortcut syntax in the private modifier. And then in here, I'll just return this dot salary. That makes sense. It's easy. You have a salary for a full-time employee, that's their pay. But for our part-time employee, maybe they have an hourly rate and a number of hours or something like that. So we'll do the same deal. First is a string, last is a string, and then we'll have hourly rate is a number and hours worked is a number. And I'm going to make both of those private. Same deal here. Great. And then in the constructor, I'm going to call super with first and last. So I'm passing that data up to the employee class, that constructor. And then in our getPay method, instead of returning that hard-coded number, we'll return the this.hourly rate times this.hours worked. And there we go. Let's test it out. So let's make one employee. We'll call this Betty. She's a new full-time employee. So her name is Betty White, and her salary is high. Let's say $95,000. And let's console.log Betty.getPay. Whoops, not get pay. Okay, and then let's make another worker. How about Bill is a new part-time employee named Bill Billerson, and we need to say the hourly rate he makes. Let's say he makes $24 an hour, and last year he worked 1,100 hours. Sure, and then we'll console.log Bill.getPay. Alrighty, and I misspelled Betty here. Okay, so this is all just to show that it works, right? We get $95,000, that's her salary for Betty, and then $26,400 is the computed pay for our part-time employee, Bill. So they have different implementations, but they both must implement getPay, right? That's the rule from our abstract class. And then again, the main difference here, there's a big difference between an interface and an abstract class, because I could write some interface called interface, payable, and it just says you've got to have a method called getPay that returns a number. And that's all it is, and that's okay. But that doesn't include any of this additional functionality that anything that extends employee automatically gets. Greet. Not much functionality, but imagine there's a lot more. First and last as properties. Anything else in here. All that this says is to be payable, you need this method. Whereas here, there's more that goes along with being an employee. You have a first name and last name. You have the greet method available. And yes, you must implement getPay, which has to be a method that returns a number. By the way, you can have an abstract class that you extend, and you can implement an interface at the same time. It's not an either or. They're just different patterns. So that's the concept of an abstract class. You mark the class abstract. You can't actually instantiate an instance of it anymore, but you can use the abstract keyword to mark methods as required when you mark them abstract, which means that in a child class, those methods must be implemented.